All right, what's up, guys? So today we're going to be solving 767 reorganized strings. And you can see right here, this is a top Amazon question. So it's quite important to know how this stuff works because you never know when maybe one day you'll be facing this question during your Amazon interview. But nevertheless, let's go through with explaining the problem and figuring out a solution on how to solve this in an optimal way. Okay, so understanding the problem is quite easy. The solution is much harder than understanding the problem, but basically all you have to do is, given a string, be able to reorganize this string in a way where we have no adjacent characters on the same position. So for example, AAB is invalid. We want it to be ABA. But also, if it's impossible to do, then we should be returning an empty string like this. All right, so I'm going to be using a more complicated example just to run through the solution. Immediately, what I thought of was doing a frequency map. What I mean by a frequency map is you take a hash map and you count the number of times your character is in the string. So you loop through everything and then you build this frequency map. For us, it'll look something like this, where we have two A characters, three B characters, four C characters, and finally one D character. All right, great. So we've built our map. The next thing that you have to kind of think of is, well, how do I pick these to be able to build the solution? Well, immediately your mind should go to using the most frequent character because we have to be able to spread these apart. So, using this up as much as possible would be a smart thing. So you put C first, great. But then what? So which one do you pick out of the three other options? You can't pick C anymore. You have to take a break from it because then it would defeat the purpose of our problem. We can't have two adjacent characters. Well, we could take the least, but then that's kind of counterintuitive. Why not take the second most or the most besides the one that we used, which would be B at this point? And that would be the smart idea. So we take B, we put it into our string. We got to remember to be updating these values as we go, because as we go, the plan is to scan these and be able to go ahead and find the most frequent character. So let's update these real quick. Okay, great. So now we got to take a break from B. We're not allowed to use B anymore. The most frequent character that's not B would be C, right? And then taking a break from C, which character would we use? Well, we're tied between A and B, so it doesn't really matter. We just take whichever one. Since A is the first one, I'll take A. Great. So we have A now. So we used up a C and an A, so let's update these real quick. Okay, so now we got to take a character that's the most frequently used, that's not an A. Again, we have a tie. Let's just take whichever one. We'll take B since it's closer. And then we'll take the second most that's not. And then we'll take the most frequent character that's not a B, which is a C. And then we basically update everything like we've done before. And now we have a tie between each one. So it doesn't really matter. We can just go in order and take every single one. And there we go. Now we have a valid solution where every single one is used and there's no adjacent characters. That was quite easy, but the problem is this is a quite inefficient solution because our frequency map is just a hash map. We need to go ahead and iterate through every single entry, finding out which value or which character has the most frequency every single time we want to put a new character into our string. And that's what makes it inefficient. It would be much more efficient if we have some sort of data structure that was able to go ahead and kind of reorganize itself as we decrease the number of frequencies in a way where we can have fast retrieval. And immediately when you think of something like that, max heap should go into your mind. So we would use a max heap to have our frequency map and be able to have fast retrieval based on the most frequent character during our run. Now, the next thing that we got to think of is, Well, how do we go ahead and immediately tell if something is impossible to make? Because it would be kind of inefficient. Again, it would be inefficient for us to go through this entire process and then figure out, well, oh, it was actually impossible. Why not figure out if it's possible or not in the beginning and then start our solution if it is possible? This is where we want to go ahead and examine our example and be able to find any patterns and be able to tell if something is impossible or possible to do. So, for example, here I can immediately tell that there's too many A's. But what is the formula that's going to go ahead and tell us it's impossible to do? Well, character, if our most frequent character's frequency is more than the length plus 1 divided by 2, then it's impossible because there's no possible arrangement where we can go ahead and escape the fact of having two adjacent characters. Is this bigger than this? If it is, then just return nothing because it's impossible. Okay, so let's go ahead and look at the solution for ourselves. We're going to use counter, which is basically a function that's going to go ahead and create that frequency map that we want. We could have just used a for loop and a manual hash map, but this is a kind of easier way of doing things. We have to find our max frequency and go ahead and apply our formula to determine if a solution is even possible. So it's the exact same formula that I was discussing before. And then we go ahead and we create our max heap. Now, the thing to keep into mind is we need a list. The reason why we need a list is because the heap queue module that we're using only takes in lists. So we turn this into a list by just looping over our frequency map and adding the entry and the negation of its frequency. The reason why we need the negative of the frequency is because Python doesn't have a max heap. If it did, we would go ahead and use it. Unfortunately, it only has a min heap, so the way we go ahead and go about circumventing this is by just inverting the frequencies. Like that, the tree gets inverted, and instead of a min heap, it becomes a max heap, so on and so forth. And here we're turning this normal list into a heap via the heapify function, and we need to keep track of our previous characters and counts, and this will be the value for our final answer. Now, the reason why we're looping through the max heap, right, or we use a while loop, is because we're going to stop when our max heap is empty. So that's about it for the while loop. Now, when it comes to taking the most frequent character, it's quite easy. All you have to do is pop the top value, because the max heap will go ahead and track the max frequency. So we just use heapq.heappop, and we go ahead and just append it to our variable that we're going to use for our answer, and we increase the count by 1. Again, if there was a max heap in Python, we would decrement, but we kind of have to do the opposite here right now. And here we are checking if the previous count is above 0. If it is, we push back the previous value that we had. Here we are setting the previous values. The reason why we kind of have this staggered effect is basically we want to go ahead and not take the previous value, since taking the previous value back to back would go ahead and result into a wrong answer. So we keep adding the previous answer one step after, and that's why we go ahead and have this step right here. And then finally, you just join everything together from the valid S list in order to build a string, because the answer needs to be outputted into a string. And really, that's about it. It is on the harder side of things, to be honest, but it is something that is quite useful to know how to do and learn. So I hope this video helped you guys. If it did, please leave a like, subscribe, and I'll see you on the next one.